teacher will never see time from you. Okay? Okay, let's go into rates of change next. Okay, I sense excitement, that's great. Okay, so I think the other time round, right, okay, we talk about rate of change. Okay, that is actually your differentiation itself. So it depends on different contexts itself, okay, what kind of change are we comparing to. Okay, in English wise, yes, rate we relate it to time, but it's not all the time that we think of rate as time, okay? No pun intended. So let's look at try 5, okay? For 13.3 and 13.4, a critical thing that we really need to be familiar with is all your volume formulas that we learn in EMATS. Especially your volume of cone, volume of sphere, and volume of pyramids. Okay? So, but don't worry, we will build that up. Is being blown up such that after t seconds the radius has grown to t cm. So that means that we're looking at the sphere. Originally it's of a certain size, t seconds later it grew to a bigger size. Okay? The question asks, what is the rate of change of volume? Okay? In this case, we are comparing over time, so our rate will have to take reference to time. Okay? Then, we're talking about volume as well, so we need to draw reference to volume of a sphere. So, the first thing we have to recall is the formula for volume of sphere. Okay, and that will be 4/3 pi r cubed. Okay? Right? So the question said that the radius actually grew up to 2t cm after t seconds. Okay? That means that our radius at t seconds will actually be 2t. So we change our r to the 2t value and we get 4/3 pi t cubed. Simplify that. 2 to the power of 3 is 8, and then t cubed, 4/3 times 8, we get 32/3 pi t. Okay? So this is how we relate the volume of sphere formula from drawing the reference from volume to radius to volume to time. Okay? Because t refers to time. Okay? Right? So if I let my volume of sphere be V, okay, I can find out what is dV over dt, which is actually the rate of change of volume. Change of volume over change of time. Okay? So differentiating this, I want us to be able to recognize that the coefficient of t cubed is actually 32/3 pi. So that's a constant itself. bring down the power minus 1. So dv over dt is equals to 32 pi t squared. Okay, as this is a contextual question, we need to actually conclude to the reference of the question or to the demands of the question. So rate of change of volume is actually 32 pi t squared cm cubed per second. When the radius is 8 cm. Okay, we have the rate of change of volume, okay, but our rate of change of volume is in terms of t. But what we're given is that the radius is 8 cm. Okay, so I need to know what is the t value in order to substitute into this. Okay, so what we can do is to make use of this statement over here, because we know that when the time is t seconds, the radius becomes 2t. Okay, so when your r is equals to 8, that means that your radius 2t equals 8. So t equals 4. Then, now that we have the t value, we can find out the rate of change of volume, or the speed that the volume is increasing at. If you want to leave this in exact, that will be 512 pi. Okay. I want us to take note, our dv over dt, if I differentiate normally, there are always chances for dv over dt to actually be negative. Okay, so we need to understand how to interpret the value, okay, if it is negative. Right, so down here it is actually a positive value. So positive is consistent with the idea of increasing. Okay, so when it is negative, then it is decreasing. Okay, so you need to be able to interpret it. We will come to that later on, perhaps not today. Something different. Earlier on we were looking at the rate of change of volume. Part 3 is now asking for rate of change of surface area. Okay, so we apply the same thing that we did for finding the rate of change of volume by first recalling what is the surface area formula for the sphere. Okay, so that will be 4 pi r squared. Okay. Then again, same thing applies. We're trying to find the rate of change. We need this to be in terms of t. So we know that the radius becomes 2t over time. So that's why we substitute r to become 2t. Okay, then we find the rate dA over dt. So 16 pi times 2 times t. And the expression is 32 pi t. Therefore, rate of change of surface area equals to 32 pi t cm square per second. And then part 4 is actually similar to part 2. Instead of asking about volume, they ask about surface area. So we do the same thing. Okay, when radius is equals to 8, that means your 2t, which represents radius, is equals to 8 as well. And t equals to 4. So when t equals to 4, we find our dA over dt. To make 32 pi 4. So that will be 128 pi. Okay, and we conclude. That the surface area is increasing at 128 pi cm squared per second. Okay. So there's an entire context in the entire question. Okay, so that's why the statement needs to be there for you to actually write down clearly what is the units being used. Okay, so you must actually have the units. Okay. Right. I have one more question, but I don't think we have the capacity to actually move on anymore. Okay. So I will leave that question to next week to cover. Since Friday we are going to do our WA1 going through. Okay. So do remember all these things that I asked of you. Go and do your file and all that. Okay. The HBL assignment, please complete it by Tuesday. Okay. Yes. Here go.